So this is the first section involving circles that we're going to look at. And so first off, we're going to be talking about angles and arcs. So angles inside of circles, specifically a central angle. So we call this a central angle, well, because it's formed in the center of a circle. So that would be this measurement. And remember, we usually use the Greek letter theta to represent an angle, a central angle. So don't forget that total amount of degrees in a circle is 360. So let's say that this is 100 degrees out here, this angle. Let's say this is 100 degrees. That means that this angle is 260 degrees. So we're going to look at all of these more in depth with a major angle and a minor angle, the larger one and the smaller one. But we could have problems like this, and so this looks a little bit complicated because we want to find x. Well, we're not given any angle measurement. However, we could look at this two ways. One, we can remember that a circle is 360 degrees, or we can remember that half of a circle, a straight line, so this straight line here is 180 degrees. So suddenly, by just emphasizing these lines, notice if I get rid of that, I have these three angles. These three angles make a straight line, which are supplementary. So what I could do is I could add up those angles, 25x plus 3x plus 2x, and set them equal to that straight line, 180 degrees. So I get 30x is equal to 180, or x is equal to 6. So that means that this angle here is 12 degrees. Now it just so happens, yes, it is in a circle, but at the end of the day, it doesn't change the fact that these are still just normal angles formed at the center of the circle. All right. Well, we also have arcs, and arcs are the distances formed around the perimeter, or the circumference. So this distance right here, this is an arc. An arc is the section, so I can even write this out. We'll define this as the section of the circumference formed by the central angle. So we're going to have two different arcs. We're going to have this one, which we call the minor arc, and then we are going to have this one out here, which is the major arc. Notice that the major arc, is larger, thus we call it the major arc. The minor arc is smaller, so we call it the minor arc. So this central angle is smaller than this central angle, and so that's why we say, hey, this is the minor arc because the central angle is smaller. So we're going to have at least two arcs, and if it's split right down the center 50-50, then we just have two semicircles. So we want to find arc length. So I think under here I have a formula. I do. So just checking. So if I have this degree, this angle degree in here, and I want to find out the length of this arc. Well, don't forget that the circumference of a circle is 2 pi r. So whatever the radius of the circle is, so that's the radius, whatever that is, I take that and I multiply that by 2 pi. So if I'm looking for a fraction of 2 pi, well, it's this fraction here. It's 100 degrees out of the whole circle. So I do 100 over 360. It's a fraction of the perimeter. See how that works? So we get 100 over 360 times 2 pi times the radius. And so let's say that the radius here is, I don't know, 5. So reducing this, I get 5 over 18 times 10 over pi. This cross reduces, so this 10 becomes a 5, and this 18 becomes a 9. So I end up with 25 pi over 9, and because we're talking about a distance, so if this is feet, then we'll say this is feet as well. And so that's it. Notice we keep this in terms of pi, and in a fraction, we do not make this a decimal. If we made this a decimal, it would become an approximation. Also, I really want to make sure you guys can work with fractions. So we have problems like this. We want to find the length of each arc. Here, we're going to find this is the major arc because this one is highlighted. So this is the arc length is going to be equal to, 210 over 360 times the radius, which is times 2 pi times the radius. So 21 over 36, that reduces to 7 over 12. So 7 over 12 times 22 pi. And we can reduce all of this to 77 pi over 6 yards. And that's the first one there. Over here we have another major arc, so we could say that this length is 270 over 360 times 2 pi times 10. Well, notice here this is actually 3/4 of the circle, so no surprise that this fraction reduces to 3/4. And we're going to multiply this by 20 pi. Well, the 20 and the 4 cancel out to 5, so we actually get 15 pi yards. This one right here, we have another major arc, so we're looking at the length is 210 over 360 times 2 pi times 10. So we already know that this fraction is going to reduce to 7/12 times 20 pi. So we get 7 divided by 12 times the 20. Well, they have a common factor there of 4. So this is going to be 5, so that's 35 pi over 3 yards. And then finally for this one down here, that's 1/4, so no surprise that 90 over 360 reduces to 1 over 4. So we get 1/4 times 26 pi, and so this becomes 13 pi over 2 feet. So those are some arc length questions, so make sure you're comfortable in doing those. And we also have these types of questions where we want to find x. So these are just like the first problems I gave, and we just use our old angle tricks. So notice these two angles here, these are vertical angles. So we get 52 is equal to x plus 59. So we actually get that x is equal to -1. We can actually see that from the setup. Over here, we know that these angles add up to 360. So 29x plus 45 plus 83 plus 145 equals 360. So the 45 plus 83 plus 145 equals 273. So we get 29x plus 273 equals 360. And then we do 360 minus the 273 to get 87. So 29x is equal to 87. And so we get that x is equal to 3. Down here, notice this is half the circle again. So if I wanted to, I could make vertical angles, or I could say 18x plus 7x plus 5 equals 180. So here I get 25x is equal to 175, and so 175 divided by 25 means that x is equal to 7. And then over here, I don't believe I addressed this issue. So here, this is showing that this is 55 degrees. That arc is the same measure as this angle. So that means that this is 55. This arc is 155, so that means that this is 155. So we can say that negative 25x plus 5 is equal to 155. So negative 25x is equal to 150. So x is equal to 150 divided by that negative 25. So we get x is equal to negative 6. And that's going to make this value positive, which is what we want. So we can measure arcs in degrees. And so actually notice in number 2, I kind of skipped right over that. We write the degree on the outside. The measure of the central angle here, that's going to be the same measure of the arc. So sometimes we can write that degree on the arc, sometimes we write it on the central angle. So make sure you know how to calculate arc length, and then also dealing with these formulas. And really, as always, know the vocabulary.